The figure shows an arrangement in which 4 disks are suspended by cords. Okay, there are multiple cords. They look like they're in a straight line. The longer top cord loops over a frictionless pulley with a force of magnitude 98 Newton on the wall to which it is attached. The tension in the 3 short cords are T1, T2, T3. What is the mass? What is the mass of each disk? So I think it's easier to actually go in reverse and find out what each mass is. So T3 is the easiest. The tension in T3 is 9.81. The tension in, so we're going in reverse. So let's look at D. Let's do that here. D, tension 3 is actually equal to the weight of disk D. Indeed, because that's the only thing it's supporting, and they're both vertical, so they should be equal. With that said, the tension is actually 9.8. Wow. And weight is mass times G. Let's take 9.81. Just, I think the math will come out nicer. I think this question was designed to be done. Otherwise, always take 9.81. But we're just doing it 9.8 because I think we'll have nicer answers. 9.8 divided by 9.8. I can't believe I actually put that in the calculator, but the mass D is coming out to be 1 kilograms. Pretty sweet. Then we have C. The tension in T2 should be equal to the weight of C. The weight of C plus the weight of D. I can put the weight of D in here or the tension. I'll use the, actually let's go with the weight. The weight is equal to the tension, so it's interchangeable. You see what I was trying to say 10 words ago. But yeah, let's just use the weight. Equal to weight of D. And this is 9.8 from the question. Again, T3. And because T3 is equal to the weight. And T2, again from the question, is 49. And this is mass of C times G. Let's quickly solve it. I've got to add plus over here. Anyway, mass of C will be equal to 49 minus 9.8 divided by 9.8. And that'll come out to a nice little 4 kilograms. Right? And let's proceed. We can actually do B and A possibly together. So the tension 1 is equal to the weight of B plus the weight of C plus the weight of D. Weight of C and D combined is actually just equal to T2. So weight B, again, it's pretty straightforward, is equal to T1 minus T2. Just a slightly little tweak because I got tired of doing the question the same way. This also makes sense. So the difference in the two forces is the weight of B. And yeah, so T1 is 58.8 minus T2, which is 49 period. And this is MB times G. Mass of B will come out to be the processed result of this equation divided by 9.8. And that's one. This is 1 kilograms. And similarly for A, we'll do the same thing, which is going to be the weight of A is equal to the total force in the entire pulley, which is 98. I have a feeling this is going to be heavy, minus T1. T1 is actually just 58.8, 98, subtracting it, and mass of A, and let's just put G over here as 9.8, dividing it. 9.8 minus 58.8, divide that by 9.8. We're getting 4 kilograms as our answer.